Okay, good morning guys. So today we are following on with the physics lessons. So last lesson you would have looked at moments and you would have touched a little bit on levers. And today we are going to follow on from that and do levers and gears. We're going to mainly focus on gears though. So today we are going to define the term force multiplier, describe what gears do and how you can tell if a lever is a gear multiplier, and explain how gears can give a bigger turning effect. For your starter, what I'd like you to consider is why do we need gears? And your keywords are moment, force multiplier, gear, wheel, and axle. Okay, so let's continue on. So why do we need gears? So have you ever tried pedaling a bike up a steep hill? And it's pretty much impossible unless you have the right gear selected to increase your climbing force. Once you are back on the straight and not going up a hill or down a hill, it's a different story. So you flick to a different gear and you can go really fast and magically make your wheels turn round much faster than you're pedaling. So gears are helpful in machines of all kinds, not just cars and cycles and bicycles. They're a simple way to generate more speed or power, or send the power of a machine off in another direction. In science, we say gears are simple machines. So what do gears do and how do they do it? So here is a gear mechanism that would be in a car. So gears change the effect of a turning force. They are used for transmitting power from one part of a machine to another. In a bike, it's gears with the help of the chain that go from the wheel to the gear selector, take the power from the pedals to the back wheel and push it along. In cars, gears transmit power from the crankshaft, the rotating axle that takes power from the engine. So the crankshaft is the rotating axle that takes power from the engine. Gears transmit power from the crankshaft to the drive shaft running under the car that ultimately powers the wheels. And there are low and high gears. So low gears, let's look at them first. So when a low gear is chosen, a small gear wheel is used to turn a large gear wheel on the output. So the output turns slower than the input shaft, and the turning effect of the output is greater than the turning effect of the input. This means that a low gear gives low speed and a high turning effect, which is good for uphill. So here we have a diagram. So we have from the engine shaft, and this wheel is going downwards, this wheel is coming upwards, and then you've got your output shaft, and these show that there is a greater turning effect on the output than there is on the input. So high gears are the opposite. So you have the opposite way around. So when a high gear is chosen, a low gear wheel is used to turn a small gear wheel on the output. So the output turns faster than the input shaft. So the output shaft here turns faster than this one here. So the turning effect of the output is lower than the turning effect of the input. This means that a force transmitted to a larger gear will cause a larger movement because the distance of the force from the shaft is larger. And that ultimately means that a high gear gives high speed and a low turning effect, which is good for going fast. So back to how they do it. You can have any number of gears connected together and they can be in different shapes and sizes. Each time you pass power from one gear to another, you do one of three things. You can either increase the speed, increase the force, or change the direction of the mechanism, or the car, or the bike, or whatever it is that's powering. So when you increase speed, so this is what happens to increase speed. If you connect two gears together and the first one has more teeth than the second one, generally that means that it's a bigger sized wheel. The second one has to turn around much faster to keep up. This arrangement means that the second wheel turns faster than the first one, but with less force. So here we have it on the red. So looking at the diagram, you have turning the red wheel with 24 teeth would make the blue wheel with 12 teeth go twice as fast but with half as much force. Increased force. So if the second wheel in the pair of gears has more teeth than the first one, which is the larger wheel, it turns slower than the first one but with more force. So if you turn the blue wheel and the red wheel goes slower but has more force. Change direction. So when two gears mesh together, the second one always turns in the opposite direction. So if the first one turns anti-clockwise, or the first one turns clockwise even, the second one must turn anti-clockwise and vice versa. There are specially shaped gears to make the power of the machine turn through an angle. And in a car, there's a differentiated or differential gearbox, which uses a cone-shaped bevel gear to turn the drive shaft power through 90 degrees and turn the driving wheels. So that is how that one works. What's the catch with gears then? So you might think that they are really helpful, but if a gear gives you more force, it must give you less speed at the same time. And if it gives you more speed, it has to give you less force. So that's why when you're going up a hill in low gear, you have to pedal much faster to go in the same direction, because you have to put in more effort and more force. When you're going along the straight, gears give you more speed, but they reduce the force you're producing with your pedals in the same proportion. So when you're going down a straight, you need to use less effort and put less force into pedaling. So if we power a gearbox in the opposite direction by turning the small wheel, we make the large wheel spin a quarter as fast but with 4 times as much force, which is useful if you want to make a heavy truck go up a hill. So what I'd like you to do now is to go on this website, watch the videos about gears, and then answer these 3 questions. So what did you find most interesting in the video? List some examples of machines that use gears in the video, and what other simple machine is often used in combination with a gear. For bicycle gears, so we talked about this just a minute ago, but a bike with 21 gears gives us a choice of 21 different gearing combinations. The front chain wheel has 3 sprockets. Your sprockets are here, so those are basically the branches that come off the middle of the gear wheel. And the rear wheel has 7 sprockets, so these things here, little bits that come out. So to select the lower gear, we use the larger rear sprocket and the smallest chain wheel sprocket. And this combination of gears makes it easier to go uphill. To select a higher gear, we use the largest chain wheel sprocket and the smallest rear wheel sprocket. So if you look at a bike, you'll see that it has 7 of these in a row. So it might have sort of 3 or 4 of these. So you've got a smaller one, and then you've got a medium one, and then maybe a bigger one. So whichever one you select depends on which gear that you select. So the combination of the large front sprocket and the small rear sprocket makes the bike go faster. So driving and driven gears, the cog that turns first is called the driving gear. So that is this one here. And the clue is in the title really, that is the one that drives the driven gear. Gears that are made to turn by this are called driven gears. And if the driving gear is smaller than the driven gear, the system acts as a force multiplier. If the driving gear is larger than the driven gear, then the system acts as a speed multiplier. So here's a bit of maths that we need to introduce here. So where there are 2 gears of different sizes, there is a small gear which will rotate faster than the larger gear, and the difference between these 2 speeds is called the velocity ratio or the gear ratio, and it can be calculated using the number of teeth that the gear has. So here's your formula that you need to know. the gear ratio is the number of teeth on the driven gear divided by the number of teeth on the driver gear. So make sure you write that down and highlight it and make it very visible for you to use later on. So if the gear ratio for a simple gear train above, for the simple train gear above, which is this one here, if the smaller gear of the driver gear is 60 divided by 15, it's 4. So that is your gear ratio. That is how you work that out, because you've got 60 teeth on this one and then 15 teeth on this one. So your number of teeth on the driven gear divided by the number of teeth on the driver gear. So this would be the driven gear and that would be the driver gear. So gear ratios are calculated by dividing the number of teeth on the driving sprocket by the number of teeth on the driven sprocket. So teeth on driver divided by teeth on driven. So for example, if the driving gear has 9 teeth and the driven gear has 3, you would do 9 divided by 3, which is 3. Now I'd like you to attempt these questions. So we've just got, I think it's 2 questions. So gear B has 36 teeth and gear A has 12. Calculate the gear ratio of this gear train if B is the driver. So because B is the driver, you do 36 divided by 12, which is 3. So that is your gear ratio. Okay, for this one, the image on the right here, you have gear B, which has 12 teeth, and gear A has 24 teeth. Calculate the gear ratio of this gear train if B is the driver. So you would do 12 divided by 24, and that is 0.5. So that is your gear ratio. So this is the final thing I'd like you to do. Look at this here. This is a paddle boat steamer. I'd like you to explain how the actions of the wheel make the boat move forwards, and how might gears be involved with the paddle wheel. And what I'll do is I will look at your answers when you submit your work, and then I will mark it there.